just right where we left it. So I was doing this. Start code space. I don't know if any of this that I'm learning it will be of some utility in the future, knowing that this VS Code that I'm using right now isn't the real VS Code and doesn't completely work as the VS Code of for computers, Visual Studio Code. I had it. I had the original. I don't know if call it original. I had the app Visual Studio Code for PC, and long ago when I was first trying this course, the Visual Studio Code app from PC works entirely different from the Visual Studio Code that David J. Malam was using. But anyway, let's continue. Make a main function and square function. So this was the main. Todos los puntos. X igual a x. We assign x to integer just to not overcomplicate it with float numbers. Integer of, you know what, let's try it with float numbers. Input what x, right? So I guess that's it for this line. Print x squared is squared x. So now we do this def squared, we put n in the middle. Now we do return n times n, and now we execute main. Now we start first charging main, then charging square, then executing main. Python. I'm going to start the timer and look it up if I am saying it correctly. First it loads main, then it loads,
then first it loads,
then first it loads main, then loads square functions. Anyway, let's try it. I forgot this here. Okay. I forgot to put the comma here. Okay, let's try that again. Two point three. 5.28. So let's put a parenthesis right here, and then this here, f this here, and let's put something here. Let's do the same in this part and this. Okay, let's try that again. Okay, let's try this again. I forgot to put a dot here. .29. Okay, now it's not just square, it's also rounded. Okay.
Is now 9. So I've implemented my very own function that returns the square of a value, and because I'm using the return keyword, that ensures that I can pass the return value of this, just like the return value of input or int or float, to another function, like print instead. And here too, there's going to be so many ways to solve the same problem. I can actually raise n to the power of 2. We've not seen the syntax before, but if you use two asterisks like this, 2 stars, that raises the thing on the left to the power on the right. Or it turns out there is in Python a function called pow for raising something to the power that takes 2 arguments, the first of which is the number, the second of which is the exponent. So there too, there's just so many ways to actually solve.
I guess that is quicker than just putting. No, it isn't quicker, it's the same thing. I guess that will help us in the future to make a better and more complex calculator.
That same problem as well. So ultimately, what have we done here? We first introduced functions. These actions are verbs, many of which come built into Python that you can just use in your own code. We then introduced variables via which you can store those return values and then maybe do something more with it. At the end of the day, too, you now have the ability to invent your own functions to solve simple problems like hello, or in the weeks to come, much more sophisticated, more challenging, more fun problems as well.
So that's it. Alright, let's see here. What is this? I want to know. That's the audio of the video. We already know that. Slides, Google Slides, PDF, source code, index, PDF. Let's open this in another window. Print hello world. What's your name? Print hello name. Okay, this is all of the video. So the video, shorts, Visual Studio. Let's see this. Let's see some of this before taking the problem set 0. Alright, so it is in this order.
CS50's Introduction to Programming with Python. My name is David Malin, and this is an introduction to Visual Studio Code for CS50. Visual Studio Code, or VS Code, is very popular.
So I'm going to put this here. I'm going to write it. Studio Code for CS50. I write it down because this will be the title of this amount of notes, this group of notes. I'm going to take various notes for this lecture. The thing I yet don't know is where to put here. Submit this form, visit this link, log in GitHub account, and click authorize CS50. Check the box indicating that you like to grant course staff access to your submission and click join course. Log into CS50 dev. I guess I don't know if it's this, which is a cloud-based version of Visual Studio Code. Is this one? I don't know. With everything that you need for the course, pre-install and install VS Code or write on your own Mac or PC. If not already familiar, be sure to watch the Visual Studio Code for a full overview. Once your code space has loaded, close any welcome tabs that might have opened by default. Execute update 50 in your code space terminal window to ensure that your code space is up to date. If prompted, click rebuild now. Submit all the problems below. Indoor voice, playback speed, making faces, Einstein tip calculator. Too much time, but we don't have to submit it exactly an hour before this day. I want to submit it as quickly as possible. So let's go back here and start with this video.
Popular program nowadays for writing code. It's technically a text editor, or nowadays really an IDE, an integrated development environment, which means it's a program that's designed for enabling you efficiently and effectively to write code in your computer. Now, it turns out you typically install VS Code on your own Mac or PC. It's free open source software, which means anyone can download it on their own computer. But typically when installing it on your own computer, particularly to use for programming with a language like Python, there's a few other steps as well. You need to install support for Python itself. You might need to configure some of the lower level implementation details of your computer just so that things work. And so instead for this course, we recommend that you use VS Code, yes, but you use it in the cloud by way of CS50's own implementation thereof on top of something called GitHub Codespaces, which is a hosted version of the same. To use Visual Studio Code for CS50, go to code.cs50.io, where you'll be prompted to log in with your free github.com account. After some number of seconds or minutes, you'll then be redirected to your so-called code space, which is your own virtual space in the cloud. Somewhere out there on GitHub servers, you will have access to your own storage space, really your own hard drive in the cloud, in which you can create files, run programs, and even organize everything in folders. You'll also have the ability to write code via that interface and much more. The interface you'll see typically looks a little something like this, whereby you'll have
first new file, no, don't, new folder, zero practices. Okay, now let's take this, Can I move it here like this? Seguro que quiero mover la siguiente cita al archivo del Lecture Zero Practices. Move. Move it. Tuk 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 tuk. Right. This is more clean now.
At the top left hand of your screen, a file explorer that allows you to see all of the files you've created over time in your account. You'll then have the ability at the top to actually write code by creating one or more tabs in which to write your programs. And then perhaps less familiarly, at the bottom of the screen, you're going to have access to what's called a terminal window. A terminal window is a command line interface, or CLI, which is very much in contrast with what you and I are mostly familiar with nowadays, which is a graphical user interface, or GUI. Indeed, everything we're seeing here is graphical by nature. There's buttons and icons and windows and more. But underneath the hood, you actually have access not only to your own virtual hard drive in the cloud, but actually your own server too. Somewhere out there on GitHub servers is your own server in a sense.
I'm sorry, I'm going to search for water. I'm going to fill the bottle. First, pants. We are back. I don't mean it literally. We are not back. We came back.
It's your own virtual server, or technically called a container, in which all of your own files will live. You then have the ability to create files, run programs, even install additional software within that server or that container, because that server container is itself running its own operating system. And the operating system it's running is not Mac OS or Windows, with which you're probably familiar, but another popular operating system called Linux. And Linux is used by so many programmers and more nowadays, not only to write code, but to run it on their own servers as well. So how can you go about leveraging this new command line interface? Well, it's worth learning just a few commands that you might not have typed previously. These commands work not only in Linux, but also on Mac OS, and also with some modification potentially on Windows as well. But if you're using Visual Studio Code for CS50 in the cloud at code.cs50.io, you'll have the ability to run all these commands and more. And here is just a few of those that you can type. I'm going to go ahead now and type code, which actually is a command that comes with VS Code itself that enables me to create new files and open new tabs. I'm going to change screens over to my own computer here, in which I have full screen VS Code for CS50. So this is my browser window full screen connected to my own code space, my virtual container in the cloud. And suppose that I want to go ahead and create my own first program called hello.py, a program written in Python. In my terminal window, I could type code hello.py and hit enter. But before I do, notice at top left in my so-called file explorer, there's technically nothing there. There's some mention of code spaces and some mention of my own unique ID, but there's no actual files or folders there yet. But when I hit enter, thereby creating a new file called hello.py, I'm not only going to see it appear in just a moment in a tab where I can edit it, I'm also going to see a graphical representation of it up here, which is only to say that this environment, this integrated environment, all works cohesively. Here we go, hitting enter. My tab has opened, my prompt is blinking here so I can start writing code, but you'll also see that hello.py not only exists, but is highlighted as the file I've opened. Well, let me go ahead and write a very simple program now. Print, quote unquote, in parentheses, hello, comma, world, which, as you'll see, if not already, is perhaps the most formative, most canonical program you can write first when writing code in most any language. I'm going to go ahead now, and in my terminal window, I'm going to run one other command that you'll learn all the more about soon too. I'm going to run Python itself, which is not only a language, it's actually a program that understands that language. And if I specify not just Python, but a space, and the name of a file that I have created containing code written in that language, crossing my fingers as always and hit enter, I've just run my own program. Now on our Macs and PCs, we're generally in the habit of pointing and double clicking on icons, or on our phones tapping on icons to launch some file or program. In a command line interface, or CLI, everything is done with the keyboard. You can use your mouse to move your cursor up and down as needed, but generally you do everything with your keyboard, not really with your mouse. Everything else on the screen can be clicked on, but in your terminal window, you'll generally see this prompt. A single $sign that does not mean dollar or currency for that matter. It's just a standard symbol that means type your commands here. And it's a visual indicator that you can type your next command. And indeed, the two commands I've thus typed are code to create my new file within VS Code itself, and then Python, which we, CS50, already pre-installed into your code space so that you had built-in support from day one with writing your own code. Now there's other things I can do in this environment. I, for instance, could control click or right click up here and see a whole menu of options with which to edit or modify that file, just like on Mac OS or Windows. I could click on some of these icons at top left, the plus icon to create a new file or a new folder. So all of those GUI conventions, graphical user interface conventions, are still there, but you will and should get more comfortable over time with the command line interface alone, which does all of those things and more for you. In fact, here are just a few more of the commands that you can use within Linux and this command line interface specifically. We'll see in a moment ls, which allows you to list all of the files in your current folder. cp, which will allow you to copy a file from one place to another. mv, which will allow you to move a file or really rename it from one name to another. rm for remove, which will allow you to delete a file. Makedir, or mkdir, which will allow you to make a directory, that is a file. Make dir into another. rm, which will allow you to move a file or really rename it from one name to another. rm for remove, which will allow you to delete a file. Make dir, or mkdir, which will allow you to make a directory. That is a folder. cd, which will allow you to change directory. Directories from one folder to another. rmdir, which
Just checking if my mic is on.
which will allow you to remove a directory. And then clear, which will just aesthetically clear your terminal window. So if, like me, you like to keep things a little bit tidy. Now, these are just some of the commands you can type within Linux at this command line, but they're really equivalent to all the kinds of things you and I already do frequently on our own Macs or PCs. Let me go back to VS Code here, and let's just try out a few of these here. I'm going to go ahead and first clear my screen as though we're starting from scratch, but this doesn't change or delete any of my files. It just clears my terminal window. I can alternatively hit Control L to do the exact same. Now I'm going to go ahead and type ls, but before I hit enter, note that ls kind of sounds like list, and indeed this command and almost all of those others were fairly succinct in that ls means list, but you only type the L and the S, no L-I-S-T. And this is true of a lot of command line interface commands, just to enable you and I to type things more quickly. A lot of these commands have this very succinct syntax and names. So here we go. I've typed out ls already. I'm going to go ahead and hit enter, and you'll see only one thing, hello.py, which is to say when I try to list all of the files in my current default folder that just automatically opens when I launch VS Code in the cloud, I only see the one file exists, which I can also see graphically here. Well, let me go ahead now and do something else. Let's make a copy of this file and call it goodbye.py, just so in anticipation of writing a second program that says goodbye world instead of hello. I'm going to do CP for copy, then the first name of the file, hello.py, then a space, and then the new name for the new file, goodbye.py, enter. And now notice nothing really has happened, and that's generally a good thing. If you don't see an error message down here, you've done well. But you do see graphically up here that both files now exist. Now I could open goodbye.py in a couple of ways. I could actually just go up here and double click on goodbye.py to open it here, or I can type the same command as earlier, code of goodbye.py, and now I'll have a second tab open here. And for parallelism, I could change this word from hello to goodbye, just so I have a second program now that is indeed the second file as well. Now, what if I decide that I don't want this file, and I'm going to go ahead and close it here, and I want to rename it and change it to from goodbye.py to farewell.py? Well, it still says goodbye.py up here, and if I type ls down here, I'll see a list of two files now that are in that same folder. Let me do mv for move, goodbye.py, and then something like farewell.py instead, enter. And you'll see that it changed up here at left, and if I type ls again, you'll see that it changed down here as well. Well, you know what, let's never mind with farewell.py. Let's go ahead and just remove this file altogether. I could go up here and single click on farewell.py in my file explorer, control click or right click, and then select delete. Or down here in my command line interface, I could do this. I could do rm space farewell, and now notice if I'm a little tired of typing out these long file names, Linux and command line interfaces frequently support autocomplete. So instead of typing farewell, I'm going to type FAR, which sounds like more than enough characters to finish the rest of my thought, and I'm going to hit tab on my keyboard, and it just finishes it for me without having to manually type the same. I'm going to go ahead and hit enter, and I'll see a somewhat cryptic message now, as many of them admittedly are. It's not an error, it's just a prompt. Remove regular file, quote unquote, farewell.py. This is just a safety check to make sure that I'm okay with deleting this file. Generally, when prompted with a question like this, go ahead and type in Y for yes or N for no, and hit enter. And now nothing bad seems to have happened in terms of any messages, but indeed, farewell.py is now gone. Well, what more can we now do? Let me clear up the screen just for aesthetic's sake here, and let's create one or more folders, not just files. Let me go ahead and make a directory here with makedir, and let me just call it folder, though I can call it anything I want. Alternatively, I could go up here to my file explorer, click on the plus icon here on the folder, and manually create a no folder as well. But here again, the goal is to focus on this command line interface instead. All right, make dir folder and hit enter. Nothing seems to happen in the way of error messages, but now notice there's not just hello.py, but a folder or directory called folder. Well, what now can I do with that? Well, let me go ahead and see what's inside. Well, in my GUI, my graphical user interface, I could click on the folder here in this little triangle and look inside, and of course there's nothing there, because I literally just created it. But let me do this now in my terminal window. Let me type ls after clicking down here, and we'll see both my folder, which by convention has a slash at the end to make visually clear that it's a folder, not a file, and there's hello.py. Let me go ahead now and change directory. Now in macOS or Windows, we would again just click or double click on the folder and see what's inside. In a command line interface, you need to be more deliberate. CD space folder, with or without the slash is fine, and then hit enter, and now you'll see that your prompt changed. There's still a $sign, but by convention, and this is a CS50 detail, though other people do this too in the world, we have prefixed your prompt with a just quick reminder of what folder you're in, so that you don't forget whether you're in your main folder where you began or some other folder therein. I'm going to go ahead now and type ls to list the contents of this folder, and of course there's nothing there because I haven't created any files. But if I do this, I could do code of farewell.py again to bring it back, but this time in this folder. Hitting enter, you'll see a new tab opens here where I can write some more code, but you'll also see hierarchically here that farewell.py is now inside of this folder. Now suppose this is a mistake and I didn't mean to do that. What can I do? Well, let me close the tab here even without writing any code, and down in my terminal window, let me do this. I'm going to type ls to confirm that, yep, farewell.py exists there, but suppose I want to move it into my main folder. Well, like on Mac OS or Windows, I could click on the file here, farewell.py, and just kind of drag it up or down to put it where I want. But let's move it. Not rename it this time, but move it using that same mv command instead. I want to move farewell.py to the parent folder. In the world of files and folders, you can think of things like a family tree. And if you want to go up hierarchically, you want to go into the parent folder, so to speak, whereas folder is conversely a child of the default folder in which we began. So I want to move farewell higher up. How do I express that? Well, another piece of syntax in a command line interface is typically this, ... is a symbolic representation of whatever the parent directory is, no matter what its name is. In this case, it's my own default folder. Doesn't even matter what its name technically is. It's not pictured on the screen. I'm going to go ahead and hit enter and watch what happens at top left in the graphical version of the same. We should see that farewell.py now pops out of the folder, and the indentation changed to imply that it's not inside of the folder now, it's alongside hello.py. Indeed, if I close the folder here, I don't see a difference because there's nothing in there as well. Let me type ls to confirm in my terminal window. There's nothing in folder. Let me now go back to my parent directory, and I can do this in different ways, and like with programming itself, there's going to be many ways sometimes that you can navigate a command line interface. Here's one. I can do cd for change directory, and then space ... to go back to the parent directory. But another technique, especially if you're a little less comfortable with this whole new world, is whenever in doubt, if you want to go back to your default directory in which you began when you logged in, just type cd with nothing after it and hit enter, and you'll be whisked away back to the starting point. Indeed, if I type ls now, I'll see farewell.py, my folder is empty, and hello.py as well. Now, I don't really need this folder because there's nothing in it anymore, so let's go ahead and delete that. I could click on it with control-click or right-click in the File Explorer, and I could delete it manually like in Mac OS or Windows, or I can use my newfound commands, rmdir for remove directory, space folder, with or without the slash, and hit enter, and because it's empty, I'm not even prompted, it just goes away quite cleanly. And a final technique that you'll find quite helpful in the context of a command line interface is that it tends to store your whole history of commands. In fact, not just autocomplete, but if I hit up and up and up and up, you'll see my history of all previous commands scrolling up on there on the screen, which is helpful if I just want to execute one of them again. I don't need to manually type it out. I can scroll up and down and find the one that I want. So this then is just a scratching of the surface of a command line interface in the context of Visual Studio Code in the cloud. Most of these commands would be the same whether on your Mac or PC, at least if you're using a terminal window that's connected to a computer running Linux, be it a container or a virtual machine or an actual server somewhere in the cloud. In the weeks to come for this class, will you have access to code.cs50.io and in turn your own code space so that you have access 24/7, 365 via a browser alone so long as you have internet access without needing to install anything on your own Mac or PC. Toward the end of the semester, if you're feeling more comfortable and would like to use the same software, VS Code, if not Linux as well, you'll be able to also install those for free on your own Mac or PC and continue programming onward even after the course's own end. This then was Visual Studio Code for CS50, and with it, a command line interface, and this is CS50 itself. simple program. And while we do, we're going to think about what a program actually is at the end of the day. So we've seen so far that we have this language called Python, and we can use Python to write programs. And Python itself has all these tools at our disposal to actually write those programs with. So among them are things like conditionals, variables, and loops, and in this case, importantly, functions, where a function is some piece of code that kind of takes an input and produces some output. You can think of it kind of like a verb that you can actually run inside of your own program. So here, I'll go ahead and make a program called hello.py. I'm typing code hello.py, and I'll hit enter. And I'll get this blank Python file. I know because it ends with .py here. And I want to call or use my very first function. And one function built into Python is called the print function, where the print function takes some text as input and produces as output this text in my terminal down below. So I'll type print here, and I'll follow it with parentheses, just like this, and I'll type hello world, like that. So now I've used or called my very first function, print. And maybe afterwards I'll also type print, maybe this is CS50P, like that. So now I have a very simple program, and I've, in this case, used two functions. Now, if you're new, you'd be asking, how do I know that these are functions? Well, it just so happens that functions have these identifiers you can use to determine when you're actually looking at a function. Now, one of these identifiers are these parentheses here. Notice how I called the name of the function, print, and I followed it with parentheses, open and closed here. So when you use or call functions, you're often going to type the name of the function, followed by parentheses, and then some input. Some functions might not even take any input. You can call them a bit like this, print, open, and close parentheses, and that would mean this function doesn't take any input, or in this case, I haven't given it any input on line 3. But I have, of course, on lines 1 and 2. So to give you an idea of what these functions will do, let me go ahead and run the program. I'll type python hello.py down below to run this program top to bottom. So that is, first we'll see the print function will run on line 1, and then on line 2, the second print function will run. So I'll hit enter here, and I should see hello world. This is CS50P from top to bottom. So we've used these functions, but as a programmer, you might also want to create your own functions. And in particular, you might want to write programs that are composed of individual functions. Now, to define your own function, that is to tell us what code should run when I call or use the function, you can use the keyword called def, D-E-F, where def stands for define. So maybe, because this is the main function, I'm about to write the main function in my program, I could just call it main, def main, like this. And I want to include an open parentheses and a closed parentheses, followed by a colon. And that then says, I have a new function that I've defined called main, that in this case won't take any particular inputs. But now if I want to tell Python, or my program in particular, what code should be run when I use this function, I need to indent those lines of code and put it inside this definition here. So why don't I take these two prints, and put it inside of my function called main. I'll indent both of them and move this back up to the top. And now I have defined, again, a function called main that doesn't take any particular input, but it does run these two functions. First, the print on line 2, and then the print on line 3. So now that you've seen how to define a function, you could think about how or who defined the print function for us, because right now we're saying print hello world, but what does it mean to print? Like, what goes into printing them to the terminal? Well, it just so happens that the Python developers defined what happens in the print function elsewhere in the Python library, which you'll learn more about as we go through the course. But for now, you can just kind of know that you can use this function, print, but somewhere else, somebody before you has defined it and allowed you to use it in this context, just like I've now defined a function called main here. So let me go and run this program now. I'll say python hello.py, enter. I don't see anything, which is maybe surprising if you're new, because here I said I'm going to define a function called main,
And within that function, I want to do the following. I want to print hello world and then print this is CS50p. But in Python, defining a function is different from running it, or this technical term called calling it. So I've defined my function called name, but I haven't called name. And by convention, I can do that using two new lines underneath my definition here, and then calling name. So I'm going to now run whatever I've defined as part of my main function here. I'll type Python hello.py again, hit enter, and now I should see hello world, this is CS50p, because this program is read top to bottom. It will first define a function called main. It will then say what functions compose that function, which functions should be run when I call this function, and then down below, I finally actually call it on line 6. And so now, in this case, you've seen that my entire program is really kind of a function. As you go off and build new and better programs, you'll see that a lot of what you're doing is just writing things that take inputs and produce outputs, and those things are called functions.
I have a DeepSeek window open.
Well, hello one and all, and welcome to our short on variables. Now, a common function of computers is telling us what time it is. And here, I have a program called clock.py to do that. Down below, in my terminal, I can run Python of clock.py and see that it is 7 a.m. in US Eastern Time. But of course, online...
Okay. First, we're going to right, so
In one here, it seems like no matter what time it is, it will always be 7 a.m. in US Eastern Time. Well, the time, of course, might change. Even if it's 7 a.m. right now, it won't be in 1 minute or 2 minutes from now. So we need a way to keep track of this value, like the time that might change while our program is running. Well, for that case, we can use a variable, where a variable is some name for a value that might change. To create a variable in my program, I can do this. I can first think of what name I want to associate with some value. In this case, I might make a variable called time. So I'll simply type time in my program. I'll then have an equals sign, which stands for assignment. I want to assign some value to this variable. What value do I want to assign? Well, in this case, I'll assign the piece of text 7 a.m. This is a piece of text because I know I have double quotes here. whatever's inside is some piece of text. So to read this again, we've created now a variable called time. We're going to assign it, using this equal sign here, or the assignment operator, some piece of text, 7 a.m. Well, the beauty of a variable is that if I give it some name, I can actually print the value inside of it simply by using the name. So here, if I print time, I won't actually see T-I-M-E, literally. I'll see instead the value being stored inside of this variable called time, or the value that it was originally assigned. Here on line 1, I'll run Python of clock.py, and I'll see 7 a.m. Well, what other variables could we create? Time zone might be something that could change too. So here on line 2, I'll make a variable called time zone, and I'll assign it the value US Eastern, again some piece of text, and then here on line 5, I could print time zone as well. Now if I run Python of clock.py, I'll see 7 a.m. and US Eastern. So variables are good for associating, in this case, values with names that I can then reuse in my program. But of course, these values might change. And again, the beauty of a variable is we could change the value associated with this name. Let's say later on, I travel across the world and I go to Nepal. Well, over there, might be 4:45 p.m. instead. My time zone will have certainly changed. I'll actually be in Kathmandu time. So originally, I had these two values for my variables. But then later on, I changed the value associated with them. Well, now if I print these two variables, let's see what we get. I'll run Python of clock.py, and I'll get the latest value that was assigned to them. So in this case, 4:45 p.m. Asia Kathmandu time. So one way we can use variables is by changing, in this case, the value we assign to them. Another way to use them is to combine them in certain ways. So here, if I wanted to kind of replicate what I had earlier, where I said some time in some time zone, well, I could do that using my variables. Here, in my print statement, I could concatenate the values inside of these variables with other strings or pieces of text. So here, I could say time and try to concatenate a new piece of text in, and then on top of that, concatenate or append some other piece of text, like that associated with our variable time zone. So what should we see? Well, I should see the value that time is storing, most recently 4:45 p.m., concatenated with space in space, some new piece of text. That concatenated with it here, our text associated with time zone, or Asia Kathmandu time. I'll run Python of clock.py, and here I'll see those values inside those variables being concatenated together. So here, this works because we're storing what we call strings, or pieces of text, inside of these variables. When we have variables that store pieces of text, this plus sign stands for concatenation, or combining our pieces of text together. But of course, our variables might store different kinds of data, not just strings or pieces of text. They could also store numbers. It turns out, in your computer, we often keep track of time as a number, the number of seconds that have passed since January 1st, 1970. So let's take a look at that approach here. Let me delete these variables and go back to having just one called time. Well, time was originally assigned this string, 7 a.m., but it doesn't have to be assigned a string. In fact, I could assign it some number. I could assign it this number here, 174160440. This is the number of seconds that have passed since January 1st, 1970. So now, if I run Python of clock.py, I will see that number down in my terminal. And now that I have a number inside of this variable, well, the plus sign means something different. If I were to type time and then try to assign it some new value, Well, I could actually take the current value of time and add on some number of seconds. Let's say 1 minute passes, for instance, or 60 seconds. Here, if I run python of clock.py, I'll see 60 seconds have passed since our first running of this program, at least according to us adding in manually here 60 seconds. So we've now seen the different kinds of values variables can store. They can store things like strings or pieces of text. They can also store numbers. When we store different kinds of values, the kinds of things we can do with those values changes. With strings, we can concatenate them, combine them together. With numbers, we can add or we can subtract. Variables are all important in our program. Helps keep track of things as they change throughout time. This then was our short on variables, and we'll see you next time.
I am confused. I thought they were going to teach me how to make a real clock. Anyway.
Well, hello one and all, and welcome to our short on return values. So let's say I want to find the area of my apartment. How much square feet is inside of it? Well, I know my apartment is about 50 feet wide and about, let's say, 20 feet long. So to find the area of my apartment, I could multiply these two numbers together to get the total area inside in terms of square feet. So I wrote a program here to do just that. I have a function here called area that takes in two parameters, length and width. What I'll then do...
No. Wait. I don't know you like I know you. Wait. How can I...
is print the result of multiplying length times width, converted of course to a string, and I'll concatenate the...
But you can also do it
this result with the other string, square feet. So let's try this out. Here in my main function, I'm calling area with two particular arguments, 50 and 20, and I should get, let's say, about 1,000.
Why don't just... You want to find the area, you first put x, that's x. Then y with this float input what y okay. Now you want to make a function that use this
1,000 square feet. I'll run Python of area.py, hit enter, and I will see 1,000 square feet. So area seems to be working just as I want it to. Now, let's imagine I had maybe more.
It isn't working as you. I would like it to work. Print.
Space to add to my apartment. Maybe I also have a yard. I want to figure out how much space I have in my yard too. Well, let's visualize that first. Back here, I have my apartment, but let's say I added on some space for a yard. Well, in this case, my yard is 50 feet wide and 50 feet long. So I need to multiply those two values together to find the area of my yard. I'll go back to my program here, and because I have this area function, I could just call it again with different arguments. So down here on line 7, let's say, I'll run area and provide 50 for the length and 50 for the width. And now if I run Python of area.py, I'll see the area for my house and the area for my yard. well and good, but what if I wanted to add these two numbers together? Maybe I want to find the total area between my house and my yard. Currently, I actually can't do that. And that's because area doesn't have what we would call a return value, at least one that I can use right now in my program. So here, area really only has what we would call a side effect, something that changes as a result of this function running. In this case, we see down below some text being printed to the screen. And that makes sense because on line 2, we call the print function, whose side effect is to print something to my terminal down below.
I'm going to take a moment to think something and to say something to my family right now. Sorry for the intermission. You have a problem with my headphones, so I can't hear you. Can you reply to me in chat? I will really appreciate. Hello, Chloe Gamer C. Can you hear me? I don't know if this was too many hours ago or just recently. Maybe in the future I will have another screen just to see the chat. Yes, can you hear me? Welcome to my stream. Now, I know you didn't ask, but I'm trying to learn how to program things. I don't know anything about programming, In fact, I don't know. I don't even know how to speak proper English. So I'm doing this kind of streams and videos to practice, forcing me to speak in a language that I don't know if I am speaking it well. I don't know if I'm talking correctly right now. But have you checked if your headphones work? I'm going to all right. I'm gonna guess you fix your problem with your headphones, so I'm going to continue.
But if I look in this main function here, where I call area both times, I actually can't really do anything with the output. I only see it.
I did here score return and terms and I can use this. I can use this to make. Alright, so let's. No. So here I could do this. Define. I guess I'm already printing it. Right, I can do this. I will erase this. guess this could work. I'm going to test it out. Let's say 100 140 square feet. I guess it works. I'm returning some value, and I could do, I guess I could do this f that. I could do this. Let's try it again. 40 square feet. So now I have a return value. I don't know if it's a side effect or
it down in my terminal. So how could I get a value from area that I could reuse in my program? Well, I should create, in this case, a return value.
I'm going to read that. I need to see the chat. Somehow I need to see the chat, because this thing of changing windows just doesn't work. Okay. Thank you for the follow, Chloe Gamer. Sorry, I don't have the alert system on.
Let me clear my terminal down below, and let me modify area to instead return to me some value. And return in this sense means that area, once it is finished running, will give back to me a value I could use in my program. I could store it in a variable, for instance. Let's type return here, our keyword to indicate we're going to return some value, and let's now type the value we're going to return. In this case, length times width. Now that I've done this, in my main function below, I can actually store this return value from area in its own variable. I could say house is a new variable, which is assigned the return value of area. So we'll read this more so right to left.
However, I have a problem with my headphones, so I can't hear you. Can you reply to me in chat? I would really appreciate it. understanding is my level of understanding English is too low, yet I'm going to use the traductor, the Google Traductor, the translator, I guess it's pero no te escucho, me puedes responder en el chat.
Area will run. It'll be passed these two arguments, 50 and 20. Area will then run. It'll run 50 times 20 and return to me that value, which I'll then assign to the value of the variable house here. I'll do the same thing down here for yard. Let me go ahead and let me actually use these values first. Now that I have these in two variables, I could find the total area by simply using the values in these variables. I could say total, a new variable, is assigned the result of house plus yard, or the value in these two variables added together. That is my total area. I'll then down below print something like this. Convert total to a string and concatenate it here. Total square feet. Let me go ahead and run Python of area.py, and now I'll see 3,500 square feet. So this return value here allowed me to take some value from my function area and use it later on in my program. It passed back to me a value that I could then use throughout my main function. Now, a common misconception with these return values. Well, here on line 2, I'm saying return length times width. But you might be inclined to also want to print the current area. Let's say I wanted to do print the value of length times width, just like this. Maybe I could both return some value and print the result. Well, actually, it doesn't quite work like this. When I say return on line 2, this means this is the end of my function. Return indicates not just what value to hand back to whoever called the function, but also when my function should end and stop entirely. So you see down below here, on line 3, this line is actually kind of more faintly written, indicating my program will never get to this line. So if I want to do both this act of printing something out, having this side effect, and returning some value, I'll need to actually move this print statement above my return statement. So here, I'll print length times width. Let's go ahead and concatenate that with our square feet as well. And then, to make things more clear, why don't we say total square feet down in main. And now what I think will happen is this. We'll call area the first time with 50 and 20. We'll print out the area of my house and then return the value, which we'll store in this variable house. We'll then call area with 50 and 50. Do the same thing now with these two values. We'll add the two results together to get total, and we'll print one final time the total square feet. Let's try this out. I'll run Python of area.py, and I'll see exactly what we wanted to see. This then was our short on return values, and we'll see you next time. I think will happen is this. We'll call area the first time with 50 and 20. We'll print out the area of my house and then return the value, which we'll store in this variable house. We'll then call area with 50 and 50. Do the same thing now with these two values. We'll add the two results together to get total, and we'll print one final time the total square feet. Let's try this out. I'll run Python of area.py, and I'll see exactly what we...
It's like a very fancy calculator, but I would like to make something that you could interact with. for example, put the x and y of the length and the width of the kitchen, and the length and the width of, I don't know, your room. And then I'm using very frequently the traductor, the translator. And add them together.
And add them. And add them.
And I would like to do that. I would like to calculate the area of the kitchen and the area of, for example, my room, and add them together. I could use some other functions, but
We wanted to see.
they aren't.
This then is our short on return values, and we'll see you next time.
Anyway, let's these side effects.
Well, hello one and all, and welcome to our short on side effects. So we've seen that functions are these things in programming languages that take inputs and produce outputs for us. Now we've seen really that there are various kinds of outputs. One of them is called a return value. The value the function gives back to us after it finishes running. But it turns out there's also a kind of output known as a side effect, which is not the return value, but anything else that gets changed while our function is running. So let's take a peek at an example here. Here I have a program called machine.py, representing some machine with some internal emotional state. Notice how up at the top here, I have an emoticon representing our machine's emotions at this given point in time. In this case, it has this particular emoticon representing something like sadness or forlornness, and so we'll see if we can make our machine more happy as we write our program. But ideally, we want this machine to say something to us, and so let's go ahead and write ourselves a function called say that we can then call inside of our main function here. So I will, underneath main, go ahead and write for myself a function called say, using the Python keyword def and the name for the function, say, and maybe say should take as input, as an argument here, maybe something called phrase, the phrase to say. And so by convention, I will indent within this code block here to write the body of my function, the code I want to run when say is called or used in my program. Well, what should say do? I think really to say something, our machine should print something to the terminal, and so we can do that with a Python function known as print, just like this. And what should print? Print, well, probably the phrase in this case, the phrase we gave as input to say. Now, if we're just using print, we haven't really added much functionality here to the say function, so why don't we have the machine able to say something, but then maybe append the emoticon at the end, so it kind of says something with emotion here. I'll go ahead and say print the phrase, but then also print on a space, followed by the emoticon itself up top here. So notice how phrase is really a local variable. It's passed as input to this function say and used within inside that function. Emoticon, though, as a global variable defined at the top of our file here, is able to be accessed by any particular function, in this case, say included. So ideally, say should then say whatever phrase we have, followed by a space, followed by the emoticon representing our machine's emotions. So why don't we try this out in the main function, which we run as we run our program here. I'll say say, maybe, oh, is anyone there? Question mark. And so if we run our machine down below, I'll say python of machine.py, hit enter, And we'll see, is anyone there with a little bit of a sad face? So we made ourselves a sad machine, but let's go ahead and try to make it happier as we go through. So maybe it could later on say something like, oh, hi, just like that. And if I were to go ahead and run this, I'll say python of machine.py, hit enter, and we see now 2 lines of text. Is anyone there? And oh, hi. Now, there's some things to fix. Ideally, the emoticon would be happy in the terminal down below when it says, oh, hi. But before we go there, let's first take stock of what we've done. Like, we've actually written a program that has a side effect. This is one example of a side effect, printing to the terminal in this case. So our function, say, has the side effect of printing to the terminal. But what other kinds of side effects might there be? Well, we mentioned earlier that a side effect, actually anything that gets changed while our function is running, that is not the return value we actually give back at the end of our function. So maybe inside of main, we could try to change the emotional state of our machine as a side effect. So let's try this out here. I'll clear my terminal with Control L, and then I'll go on to line 6 here, and before we say, oh, hi, let's try maybe making the emotion a little happier in this case. I'll say colon D for the big smiley face, and ideally, if we were to run this program, we'd see, is anyone there? With a bit of a sad face, followed by, oh, hi, with a bit of a happy face. I'll run python of machine.py. We seem to still have ourselves a sad machine, so how can we improve this? Well, notice first here that emoticon, if you can see very slightly, is grayed out. And this is because Python, by default, wants us to specify that we're trying to change some global variable inside of a function that's more local scope. So our side effect that we want to have happen is to change this global variable, but because this isn't always desirable, Python wants us to explicitly specify what we're going to do. So to do this, within the main function, what I can do is use this keyword called global. And I can specify after global the global variable I want to make accessible and modifiable within this particular function. And the key thing there is it's now modifiable, not just accessible. Notice how in say, it was accessible to us, emoticon was. But in main, it wasn't modifiable. I couldn't update this variable. If I now say global emoticon, I'm able now to modify the actual value of that variable as a side effect. Not the return value here, but just a side effect as this function runs. So here again, we have our global emotional state for our machine. We then have our function called main. Within that function, we say we're going to be able to change this global emotional state that we called emoticon. We'll first say, is anyone there? Change the emotion, and then say, oh, hi. So let's try this out. I'll go ahead and run python machine.py, and there we go. We've now seen another version of a side effect, one that changes some global variable. Now, in programming, this may or may not be desirable. If you have a global variable that is accessed across many other functions, it can be hard to debug your code if that variable gets modified across all these different functions. So keep in mind, when you use side effects like these, make sure it's good design, right decision to actually make when you're writing your program. But here we've seen 2 examples, printing the terminal, modifying some global state. There are others too, but I'll leave that for later time. We'll see you next time.
Okay, let's try and do the same as machine.py. Yes, code machine.py. Let's try and do the same as he does. It was first assign a variable and emoticon, then define main after that we use global x, then
in a program.
Say, it didn't. This doesn't go here. It goes this here. Say. Phrase, say, phrase, this case goes the X. I guess that's right. Well, he puts an space between. I don't know if I will do that. I guess I can. So here that took like that. Yes, print. Phrase. And space and variable. Global X. So that. There. Python machine.py. Oh, hi.
This is because Python by default makes sure it's
so global, you put in front of global a value, a variable, and it changes. Next time you load it, if you show effect.
It's good design, right decision to actually make when you're writing your program. But here we've seen two examples: printing a terminal, modifying some global state. There are others too, but I'll leave that for later time. Of a side effect, one that changes some global variable. Now, in programming, this may or may not be desirable. If you have a global variable that is accessed across many other functions, it can be hard to debug your code if that variable gets modified across all these different functions. So keep in mind, when you use side effects like these, make sure it's good design, right decision to actually make when you're writing your program. But here we've seen two examples: printing a terminal, modifying some global state. There are others too, but I'll leave that for later time. We'll see you next time.
Okay, so I guess that's all. So I have to go to the problem 60 now. Okay, I'm going to put you here so I can fill this. I can fulfill this. In order to submit problem says you need an account and you could have a particular service with which to store code and collaborate with others. If you don't already have one, you should. Take care to remember. If you don't already have one, visit and create an account for free. Take care to remember your username and password. If you prefer not to provide GitHub with personally identifiable username and email address, one that includes your name, you're welcome to create an account using an anonymous username and some other email address. use GitHub if you choose to provide personally identifiable username or email address. Material you submit for the course to GitHub and our feedback on it also will be personally identifiable by GitHub. See GitHub privacy statement and oh, I don't remember my GitHub username. Let's check it out. So it was this one. Come to send. Okay. Which category do you feel you fall into? What's your level of comfort with computers? You feel you fall into? What's your level of comfort with computers? In CS50, etc. I'm among those less comfortable. I'm among those less comfortable. I'm going to be really honest with you. I really don't like to be this much hours in a chair. I don't like to be sit down for extensive periods of time. How much programming experience would you say you already have? None. I don't have any experience programming. How many computer science courses have you already taken? If any, zero. None. I have reviewed and understand the course policy. I had to read this. I have reviewed and understand the course policy on academic honesty at this link, particularly its regret clause exerted here. If in doubt as to whether some act is reasonable, do not commit it. If the course determines that you have committed an act that is not reasonable, you may be deemed ineligible for a certificate. If you commit some act that is not reasonable but bring it to the attention of the course instructor, you may be deemed ineligible for a certificate. If you commit some act that is not reasonable but bring it to the attention of the course instructor within 72 hours, the course may reconsider that outcome. I don't know if I should be in record reading this, saying this, or even taking the course. But I will do it anyway. I understand that the CS50 staff will conduct random audits of submissions to ensure compliance with the course academic honesty policy and the language cited above. The consequences for the staff determine an unreasonable act as occur may include but are not limited to removal from the course and notification to EDX that you have committed an unreasonable act, revocation of previously issued CS50 certificates, and denial of issuance of CS50 certificates or verified certificates. That means if I somehow commit anything that the staff doesn't like, then all I'm doing right now and all I ever could do will have no value if the staff determine that I have committed an unreasonable act. So could may include. Alright. Okay. So now I guess I think I forgot my password. This is still put there, so yay, I didn't forget my password. New record. So CS50 Python C status will grant the teacher of this course access to my submission. Join course. Yay! I'm in Harvard. So recent link, log in with your GitHub and click authorize CS50. Check the box indicating that you like to grant course staff access to your submission and click join course. Log into CS50 dev. Okay, and this is already do this. What are they going to see what I was? Yes, they are seeing my code space. I guess it's loading up. Loading. Rolling. Okay, I'm going to close this window. I'm going to close this one also. I'm sorry if you can't see anything. I'm going to change the window. No, not yet. Log into CS50 dev. This version of Visual Studio Code, everything you need when you start. If you are already familiar, be sure to watch the Visual Studio Code video for once your code space is loaded. Close any welcome tabs that might have opened by default. Execute update 50 in your code space. Terminal window. Alright. If prompted, click rebuild now. Submit all the programs below. Alright, so now I have to put something in the terminal window of my code space. Here goes update 50. I'm scared. Tengo miedo. I just can feel that somebody's watching me. I have no privacy. Whoa. rebuilding code space. I hope they don't erase any of my files. I wouldn't like to write all of that again. Okay, it's almost time for me to go. I had to do a couple of stuff, so maybe I'm going to let it maybe I will leave it right here. Yes, I'm going to do that. Okay guys, the stream is over. See you in the next time. Bye bye.